Hello everyone, my name is Dr. Kaushik Bal and I will be the instructor for this course on PDEs. So this is a course which is basically intended for physicists, scientists and engineers. So you may be in your second year, third year or fourth year and you can take this course, clear? And the thing is, what is the basic idea of this course? So essentially what we are going to cover is this. We will start with some ODE theory. Okay, in ODE we are going to learn first of all Sturm-Liouville problems, Liouville problems. So what are Sturm-Liouville problems? Essentially these are eigenvalue problems. Okay, eigenvalue problems. So you will be given a boundary value problem, ODE, so second order ODE, similarly something like this. Yes, this is an example basically. Let's say y at the point A is alpha and y prime at the point B is beta, something like this. Yes, this is just an example, and we need to find solutions, non-zero solutions for which lambda does it admit. So these sort of problems we actually talk about in Sturm-Liouville theory. And what we are going to do is we are also going to learn some properties of this equation. So just by looking at this equation, what can we say about the eigenvalues, whether they are real or not, how many eigenvalues are there, how many eigenfunctions are there, those sort of questions, right? Those are Sturm-Liouville problems, and we are going to need this Sturm-Liouville theory to study our second order equations. Okay, the second part which we are going to do is one of the foremost important theory in all of mathematics probably. This is called Fourier analysis. So basically we are only going to look at the Fourier series part of it. Okay, so essentially here the idea is, let's say given any function, let's say f of x, we want to write it in terms of some series, yes, some infinite series of course, containing cosine nx and sine nx. Yes, cosine nx and sine nx. There is the idea why we suddenly start with cosine nx and sine nx. So we will talk about this, that why we need this sort of functions, or can we do away with other functions. Okay, and then we'll talk about some properties of this Fourier series, and we will also look at how we can represent different sort of functions in terms of Fourier series. This is very much important in signal theory. So whenever you have a wave or light, let's say, yeah, so in those cases, those signals you can actually interpret it in using much simpler signals. So those signals f of x, you can interpret it using much simpler signals like cosines and sines. So this is about this. Then we'll look at some first order equation, which is method of characteristic. First order equation, okay, method of characteristic, which will be followed characteristics. So this will be your PDE part. Okay, so this is the PDE part which we start. Then we'll look at canonical form. So basically, let's say if you are given a second order equation, okay, canonical form second order. Let's say you are given a second order equation, okay, and you want to find, do a change of variable under which this becomes a much simpler problem. So and you can actually show that it will actually look like either of the three problems, either it is elliptic, parabolic or hyperbolic. Yes, and then in the last part, the most important part of this thing is we are going to talk about some elliptic equation. Basically we are going to talk about Laplace equation, because by canonical form we will show that actually you can reduce all of this into basically which looks something like Laplace equation, heat equation. This is the equation which actually models the parabolic version. Okay, and then we have wave equation. This is the hyperbolic one equation. Okay, so we will learn how to solve this using separation of variable. Clear? Okay, so this is more or less the gist of the course. We will learn some theory but very few. Mostly this is intended for physicists or engineers, as I already told you. So it will be mostly like how to solve the problems and some basic properties of how to what can you say about the problem just by looking at it. So those sort of problems. Okay, so I think you are going to enjoy this course. So thank you very much.